Hi, my name is Elena Noltenius, and this is my CS2316 final project. So, my point of interest was based on curiosity and how poverty levels correlate with drug and substance abuse. I come from El Salvador, a third world country where poverty levels are very high, and therefore wanted to explore this relationship in order to see how poverty impacts drug abuse in general. So, for my data collection process, I started with my CSV file, which was obtained from data.gov, which contained information like name of schools, national school ID, IPRS values, which are index to poverty ratio values, and latitude and longitude values based on schools, neighborhood location. The dimensions are shown, and then inconsistencies like the table was organized by latitude and longitude values instead of states were a problem that I had to fix. Then for my JSON file, the JSON did not have many inconsistencies, and then it was obtained from data.gov as well, which was organized by year and state and contained information like drug type, number of deaths per drug, total number of deaths per month, etc. Then for my HTML file, the HTML was obtained from Wikipedia, which contained information about drug overdose death rates per state throughout the years. I focus on data only from 2019 and 2020. Inconsistencies like unnecessary tags were things I needed to deal with. Then for my data cleaning, starting with the CSV, I used a new module called GeoPy to convert latitude and longitude values for each school neighborhood to states. I also used pandas to read through the original CSV and shorten the table up because it was too large. I used CSV module to read through each row in the modified table and labeled the values in each row accordingly. I then found the state for each school neighborhood using GeoPy. This took over 2 hours to run, about 2 hours and 40 minutes, and I cut the table twice. But then after this, it gave me an ordered list of state names, and lastly, I attached this list to the original data frame as a column using pandas, and this is my result. Then for my HTML, I used Beautiful Soup to web script the website. I accessed the correct table using find all and then table. I accessed data rows and looped over each row in order to label each value in a row. Only I only chose overdose rates for the years 2019 and 2020. I stripped the states column from the specific inconsistent tag, which was an asterisk, and from other unnecessary tags. I appended the labeled values for each row as a list of lists in order to write them out as to a clean CSV. Then for my JSON file, I read the JSON file using the .load method. By loading the JSON dictionary into a Python dictionary and accessed the largest value from the dictionary, which was a list of lists. I then looped over this list of lists and filtered out the information I needed from the years 2019 and 2020. Some of the information was the state, the drug type, the year, month, the number of deaths per drug, etc. I then wrote this into a new CSV and read the CSV using pandas to modify the structure of the table and clean it up. Then my insight number one was to find extreme poverty school percents based on low IPR-EST values. The main goal of this function was to make an analysis between US school neighborhoods with extreme poverty values and total number of school neighborhoods being considered per state from the years 2019 to 2020. In order to determine what schools are considered to be in extreme poverty, I did some research and learned that the lower the IPR, that the lower the IPR value, the higher the poverty in the school neighborhood. Therefore, I counted the number of schools in extreme poverty per state. I chose my IPR value to be below 350 and compared it to the total number of schools per state to find an extreme poverty percent column. Finally, I sorted the table from highest to lowest poverty percent, and the main insight is being able to determine which states possess the highest poverty neighborhoods in order to later compare these states with states having high drug consumption. For my insight number two, source validation and accuracy was the main goal. I compared the same information from two different sources, drug overdose death rates per state between the years 2019 and 2020, to test rates accuracy. One of my sources came from Wikipedia, and I averaged the overdose death rates for these years per state, and then my other source came from the data.cdc.gov website, which was originally a JSON file. And even though the data frame I created from it during phase two was organized differently, it provided me with enough information to calculate the same overdose rate. I then merged these two tables by their common column, state, and calculated the final average as an average drug overdose column between both sources. Next, I sorted the final data frame by this average. From this, I can conclude several states up in the Northeast had a high drug overdose death rate between 2019 and 2020. This insight will be useful to me to compare these states with the states that have a high IPR value to see if I find any correlation between poverty and drug abuse in the US. So for my insight number three, the goal was finding state with the lowest IPR values or states with the lowest index to poverty ratio values. I used pd.read CSV and the group by function in order to obtain the state with the lowest mean IPR est value. I grouped by state. I then used the mean aggregate on the IPR column and sorted by the mean IPR in ascending order. This function gives me the significant insight of revealing the states possessing the poorest U.S. school neighborhoods from 2019 to 2020, which I can conclude seem to be mostly underdeveloped and rural states. For my insight number four, finding drug with the greatest mortality rate was the goal. From my original JSON file converted to a CSV, I masked and changed some titles to my data frame in order to organize my table in a way where insights can be drawn clearer. I then created a separate data frame from this one, sorting out the deaths per drug from the entire US in order to only focus on deaths per individual state, and used group by on drugs and aggregate sum on deaths to get the overall highest mortality overdose drug between the years 2019 and 2020, which were opioids. It is not uncommon that these results demonstrate opioids to be one of the leading causes of death among all other drug types, since there is not much public awareness on the addictiveness of this prescribed drug. So for my insight number five, calculating overdose percent difference between 2019 and 2020 was the goal. I wanted to make a comparison between these 2 years for drug overdose death rates. From my function, I separated the original data frame into two separate data frames, one data frame per year, and then I calculated the ratio difference and percent difference between the years 2020 and 2019 for overdose deaths. I then included these results into a new data frame and sorted the percent differences from greatest to least, using the absolute value. To find the District of Columbia was Virginia and Maine. They were the states with the biggest drug overdose increase from 2019 to 2020. For my visualizations, for the top right, my original hypothesis was that people in neighborhoods with high poverty levels are more likely to engage in illegal drug consumption and substance abuse, increasing overall drug overdose rates in the area. Based on my bar plot, it is clear that my hypothesis is rejected since lighter colored bars represented higher drug overdose rates, and most of these lighter colored bars show low to intermediate extreme poverty levels, so bars are not very high as you can see. In conclusion, there seems to be a slight trend showing the opposite. The higher the poverty levels, the lower the average drug overdose in a state. The bottom right is a pie chart showing the states with the highest percent drug overdose increase from the years 2019 to 2020, as shown by the chart. Although there is not a large significance increase in drug abuse and overdose, there is still a small overall increase in many states. It is important to pay attention to trends in illegal substance abuse throughout the years, as it can forecast and predict positive or negative patterns in later years. So the left visualization is a 3D scatter plot which demonstrates the relationship between IPR values and the total overdose deaths per state. It is also color-coded according to the drug with the highest overdose for each state. As stated before and clearly shown in this diagram, the dominant drug for overdoses is shown to be opioid around the nation. So my overall results and conclusion. My initial hypothesis was rejected after conducting analyses because trends showed higher IPR value states to have a greater number of drug overdose deaths. There is a trend suggesting lower IPR values lead to fewer overall drug overdoses per state. Rural and underdeveloped states seem to have lower levels of drug overdoses, and my greatest challenge was cleaning my original CSV and converting all latitude and longitude values to states using the new GeoPy module, which took 2+ hours to run. My takeaway is that we should